Okay, so problem 7 states an exam is used to access readiness for college. In a recent year, the mean test scores was 25.35 and the standard deviation was 3.27. It states, is a test score of 31.37 significantly low, significantly high, or neither, and explained. So in this particular problem, we are applying the range rule of thumb. Essentially, the range rule of thumb states that 95% of all data values lies within the mean, right? So let's just look at a picture. If I drew out a number line, let's say, this number line represents your test scores. Okay. Now, the test scores in this problem states that your mean, which is located in the center, should be somewhere around here. That would be your 25.35. Okay. So we say mean equals that value. Oh, sorry. I didn't draw the mu correctly. Here's your mean. All right, good. Now, the standard deviation is 3.27. So what we're going to do is we're going to subtract the mean minus 2 times the standard deviation, and we're going to add mean plus 2 times the standard deviation to get the lower and upper bounds. Okay, so how does this work? We're going to take 25.35 and subtract 2 times the value of the standard deviation, 3.27. And we're also going to do 25.35 plus 2 times 3.27. If you have a calculator and you work this out, can somebody tell me what they get? Yeah, Nicole?
Which one first?
We could do the lower one first.
1881.
1881. So this value turns out to be 1881. And the upper bound? 3189. Very good. So 95% of all the data values should be between 18.81 to 31.89. Now, this question asks us if we have a test score of 31.37, is it going to be significantly low, significantly high, or neither? And here's how we solve this. So going back to our graph, again, this is within 2 standard deviations of your mean. Anything in the middle is considered not significant. When I say anything, I'm talking about, in particular to this problem, the test scores. If you have a value or a test score that's below the lower bound of the 18.81, that's called significantly low. And above the upper bound is called significantly high. So let's just call this value 31.37. Let's just call that X. If I think about my number line, where is X located? Say it louder. How would you plot 31.37? Where is it located? Say it again. Next to the what? Where would describe it? Describe its location. Is it in the middle? Is it in the middle, to the left? The middle of what? There you go. So if I were to plot this on the number line, 31.37 should be right next to 31.89. But since it falls in the middle, right, we say that it's not significant, okay? So 31.37 is not significant because it is between the lower bound of 1881 to 31.89. 31.89 or to your upper bound of 31.89. And that's it. That's how you would answer that question. All right. Let's say I chose another X value. Okay. Let's say this time we say let X, I'll call it X2. Let's say X2 is equal to, I don't know, let's make it 17.76. Do you think 17.76 is going to be significantly low, not significant, or significantly high? Significantly low. Why? 1776 is significantly low because why? How can I describe it in words? What makes it significantly low? That's right. That's it. It's because it's less than the lower bound of 18.81. All right, 18.81 and 31.89, those two particular values separates or distinguish what is a value, why is a value significantly low versus why a value is significantly